So for this problem, you've been asked to find the particular solution. So this means we are going to separate and solve. So we'll have dy dx equals 2 minus 1 over x squared and y minus 2. I will multiply both sides by dx, and I'll divide the right side by y minus 2. And we'll end up with dy over y minus 2 equals 2 minus 1 over x squared dx. And always our next step is to integrate on both sides. So the natural log of absolute value of y minus 2, the integral of 2 is 2x, and before I integrate this, I'm going to write it as negative 1 times x to the negative 2. So I can apply the power rule, we'll add 1, and divide by that new power of negative 1, giving us positive 1 over x. Because this negative 1 can come back down, negative and a negative is a positive, plus c. Now I can use my initial condition of x equals 1, y equals 3 to get natural log of 3 minus 2 is equal to 2 times 1 plus 1 over 1 plus c. Or natural log of 1, which is just 0. So I'm going to write that. Natural log of 1 is 0 equals 3 plus c, or c equals negative 3. Now I can go back and plug that c in. Natural log of y minus 2 in absolute value equals 2x plus 1 over x minus 3. Now I'll undo a natural log with an exponential. So this e is going to be the base on both sides. Undo, I get plus or minus the quantity y minus 2 equals e to the 2x plus 1 over x minus 3. And so we have to decide between this plus and this minus. And we'll use our initial condition for that. When x is 1, y should be 3. So when I plug a 1 in, the right side becomes y to the 0, which is equal to 1. And on the right, we should have 3 minus 2. So if we have 3 minus 2 plus or minus, does that equal 1? Well, yeah, if I have the positive root, positive 1 equals 1. So it would be wrong to use the negative. So we know the negative root, or the positive root is the correct one. So I'm going to write this as positive y minus 2, or just y minus 2, equals e to the 2x plus 1 over x minus 3. Add 2 to both sides. Final answer, y equals e to the 2x plus 1 over x minus 3, all plus 2.